Okay, let's start with the first one. We're going to first look at our limits of integration. You guys remember what those are? I taught you guys a couple days ago, a limit of integration. Do you remember what those are? What are those? Exactly. It's these little numbers here. And today we're going to keep it straightforward, right? This one is going to be lower than that one. So least to greatest. Okay. So just make sure you do that first, because you might, like you see in number one, you might get more than you need, right? So we're going from -9 to 9. Is it asking me to find the definite integral from -9 to +9? It is not. So make sure you know what you're actually trying to figure out in terms of the area under that curve. So first thing I notice is I go from -9 to -7 is a rectangle. So I'm going to break this down from -9. Is it +2? Yeah, -2. So I'm going to break it down into this. Yes. Can I not see? Or can you not see? I can see. Yes, Alan. Do you have a pass?
No, Mr. Pickens.
You're going to G-check? Okay, maybe 2024 he'll start doing that. Okay, then we're going to go from -7 to -5. What is that shape from -7 to -5? Trapezoid. Okay, and then I think our last one here, because we're stopping at -2, is a rectangle. Correct. We're now going to find essentially a amount of 3 different areas and add them together. Do you need something to run? Okay. You okay, Jordan? You just don't want to do it? Okay. Just taking this one off? No worries. All right. We'll sub you out. Did you get the new one though? Yeah. All right. So hopefully the first one and the third one, right? This first one and this third one will be the most straightforward, because we're just doing rectangles, which is length times width. So let's write some numbers here. So this first one, I'm going to have, this is 2 units going from -9 to -7. And then if you count, right, from the x-axis, 1, 2, 3, all the way up to those 2 dots, that's 4. Right, so what is that area going to be in my first rectangle? 8. So I'm going to put a big 8 there. I'm going to skip the trapezoid for a second. I'm going to come back to it. Let's go to the third shape, that other rectangle. -5 to -2, right? Counting, that's going to be 3 units, right? In terms of my length, 1, 2, 3, 4, 5, 6. So what's 6 times 3? 18. So the area for that one is 18. All right, so now I'm going to find the area of this trapezoid. I'll change colors. So remember, like we did yesterday, right? This distance in the x values from -7 to -5 is going to be my h, my height. So that's going to be a height of 2. And if you remember the formula, right, it was base 1 plus base 2 over 2, or times a half, and then times the height. Okay? So we just found the height. We already found base 1 here, right? This is that other side of that rectangle, so that's going to be a 4. And then this one here, again, we already found with this side like here, so that's going to be a 6. So we're going to have 4 plus 6 divided by 2 times, what was our height? 2. Times 2. So remember, those just cross out. All right, so we have, what is 4 plus 6? Just 10. If you add those 3 numbers together, that will give you the value for the definite integral from -9 to -2. All right, so what is 8 plus 10 plus 18? 36. And that's it. That's how you do it. Let me zoom back out so you can see the whole thing.
We are zoned out in the trapezoid part.
We're trying to find the area under the curve for my limits of integration. So the problem states -9 to -2. So essentially, Alan, from -9 to -2, I chop up that area under the curve into shapes that I know how to find the area of. So I chopped it up into a rectangle, a trapezoid, and another rectangle. Found those three areas, and then added them together. Okay, Amanda, your question?
No, I got it.
Okay. Yep, sorry. Any questions on the first one? Again, I mentioned this. I'm going to go back up in a second when Anna's done. If you don't want to use the trapezoid, you don't have to, right? You could have made this into a rectangle and a triangle, right? So it's up to you if you'd rather do a rectangle and a triangle and add another shape. It doesn't matter. It's the same thing. Okay?
Wait.
Yes.
So for a triangle, it would just be 1/2 times the base center.
Exactly. Yes. Right. I'm just saying if you like, Gaia, if you're doing it at home, you're like, oh man, I forgot what the area of a trapezoid is, like kind of the formula, right? And you don't have Google for whatever reason, right? Can I go to the second one?
Yes.
Okay. Oh, Alan, one thing I want to, sorry, I'll go ahead.
Is it with the midpoint?
No, so this one we're making our own shapes. So we're not doing any like right or left or midpoint. We're just making whatever shapes we can to graphically find the area.
Straight, like, lines?
Yeah, you get to do the lines. One thing I did say, Alan, before you walked in is make sure at the beginning you check your limits of integration because this one said from -9 to -2. You'll notice we're not even using over half of the rest of it. So just make sure you know where you're stopping.
No, you just answered.
Okay. All right, let's go to number 2. Let's go to the second one.
Wait, is it possible that there's gonna be like a graph of numbers like every time?
No, not yet, not today. This is, well, I guess what I'll say is from your understanding of the integral symbol from last semester, right? The going backwards from this means that this right here technically could be like the derivative, right? And we're going backwards from that. But that's not yet. That's not happening yet. You want to write this one down?
Yeah.
Excellent. I love it. You're good. I was making sure Georgie's facing forward. She's fully ready. She's locked in. All right. Ready? Highlight or circle the limits of integration. So we're going from -7 to 5. Again, it's your choice on how you want to divide it up. I'm going to do -7 to -3 is a trapezoid, but you could turn that into a rectangle and a triangle. Then -3 to +2. Is that a square? 2, 3, 4, 5, 1, 2, 3. It is a square, right? I mean, I could say it's a rectangle. It is a rectangle, right? But even more specifically, it happens to be a square. All right. And then finally, it finishes at this +5. So I'm going to have 3 shapes: trapezoid, square, and then triangle. That will, when I add those up, I'll find the area under the curve from -7 to +5. So I like to just do this notation. Again, you don't have to do this, right? When you're doing it on your own, if you just want to go faster, that's fine. But this helps me kind of organize my thoughts. Yes.
Wait, so then what happens with the DLX? Is the DLX telling us that
It's a dummy variable. It just means that it's with respect to x.
so that there's D of Y, we'll be doing the Y that next Y?
Yes, but it would say f of y, right? And right now we're just going in the x direction. Okay. Then I have -3 to +2. And then the last one is +2 to +5. All right, so let's find the first one. Is the first one my trapezoid? All right, let's do the trapezoid. Okay, so what's going to be my height for my trapezoid? 4, very good. Let's find our bases. The first base is 3. The next base is 5. All right, let's see if we can do this in our head this time. Right, remember it's the first base plus the second base. So what's 3 plus 5? 8. Divide that by 2. You get 4 times the height. So what's 4 times 4? 16. So this area is going to be 16. Plus, let's do the next one. Next one is a square. -3 to +2 is 5. We just did this side length there as our second base in the trapezoid. So 5 times 5 gives you 25. And then last but not least, we have a triangle. All right, what is going to be our base? 3. Our height, which you already counted before. All right, and remember the area for this is you multiply the base times the height. So what's 5 times 3? 15, and then divide that by 2. So what's 15 divided by 2? 7.5. Very good. All right, let me zoom out so you can see everything. All right, so we have 16 plus 25 is 41. 41 plus 7.5 is 48.5. So that is our area under the curve between -7 and +5.
So that dx doesn't matter.
The dx is just a dummy variable. That's the notation that I want you to get used to writing.
We have a free response.
Wait, how come you didn't put it on the side?
I don't know what you're talking about. I did. I did.
You did.
I just put it on. I'm just messing. Any questions on number 2? Did you have a question, David? Or was that Gael?